Welcome everybody. Good afternoon, everybody. Welcome to the latest installment of the National Nanotechnology Coordinated Infrastructure webinar series. This is a semi-monthly series highlighting topics in education and outreach, computation, societal and ethical implications, which will be today, and innovation and entrepreneurship. And so I'm going to turn it over to, before I turn it over to my colleague Jamie Wetmore to host today's webinar, just a quick announcement. If you missed any of our previous webinars, you can find them at our YouTube channel, which you can find by just Googling YouTube and NNCI, and it should be the first item that pops up. And you can also find information about future webinars on the NNCI website on the events page there. We will be having a number of other webinars coming up in the months ahead of 2022, and I think we may even have one in March, although the information is probably not posted yet. So just keep checking back every once in a while, or you'll see the information where you normally get NNCI events information. And with that, I will turn it over to Jamie Wetmore from Arizona State University.
Thanks, David. Can you all hear me okay? All right, cool. I am so excited that Kristen Kulinowski has agreed to join us today. Let me just give a little bit of back history of Kristen. So she was a chemistry professor, actually, and then did 2 years as a science policy fellow with Representative Markey in Washington, D.C. in Congress, and then transitioned directly from that to being the executive director of an NSF-funded Center for Biological and Environmental Nanotechnology, and she did that from 2002 to 2011, something like that. Is that right,
Yep,
Kristen?
that's right.
Along the way, being director of the International Council on Nanotechnology. So she spent a lot of time thinking about nanotechnology for a good section of her life. And I'm hoping this doesn't insult her, but part of my academic training is history. And it is frightening to me that some of my work and some of Kristen's work could now be considered historical in the world of nanotechnology. And so a big part of what we're excited to do today is to sort of look back a little bit, but also very much looking forward, because Kristen is now transitioned back from academia to being in Washington, D.C., to playing a major role in the policy world as the director of the Science and Technology Policy Institute. So thank you, Kristen, for joining us. We're going to focus on the environmental aspects of nanotechnology, since that was so much of what you did and were involved with. But I just maybe I'll start with just a quick question for you, is sort of how you first got started. What are your first memories of nano? How did you all of a sudden go from being a chemistry professor to focus more and more on not just nanotechnology, but nanotechnology and policy?
Yeah, so I was a faculty member at Rice University, non-tenure track faculty member, and I was thinking about my next steps because it wasn't a permanent position. I had been doing research in the lab of Professor Vicki Colvin, who's a tenured faculty member, and I was making colloidal crystals. These are bottom-up synthesis of small particles that assemble themselves into an array that is opalescent, so they refract light in a very beautiful way, similar to how butterfly wings are structured to have that shimmer to them. And so I was doing research in her lab as well as teaching a lot of chemistry classes, and she said, hey, if you want a career in academia, it's really good to write some grants, to have some experience writing a major grant. I'm thinking of putting in Rice for this new center. Would you like to help me put the proposal together? And that embarked us on a nearly 1-year journey of applying for National Science Foundation Nanoscale Science and Engineering Center, or NSEC. And to be honest, we didn't think we were going to get it because it was the first class of nanotechnology research centers funded by the government, funded by the National Science Foundation in the very, very early days of the National Nanotechnology Initiative. And we were going up against all of the other big name universities. But lo and behold, over the course of several months, we passed through the pre-proposal stage, the proposal stage, the site visit stage, and eventually we were awarded this research center, the Center for Biological and Environmental Nanotechnology. We call it CBEN. And there was a position for me in the center doing educational outreach. But before we got the center funded, I had also applied for a congressional policy fellowship. So I told Vicki, I'm doing this. And she said, okay, you go do that and you come back and then there will be a place for you. We'll hold the position as the educational outreach coordinator in the center. And so I did. I went off and I had my adventure. It was just 1 year in DC. And then I came back to Rice and worked in the center for the next 9 years.
Right, so a big part, we don't have a lot of time, a big part of what we're going to try to get through is the title of this talk, so the wow to yuck to meh. So is CBEN the start of or a response to yuck, or are we still in the wow stage at that point?
So in the latter part of the 1900s, really, latter part of the last millennium, there was all of this excitement about nanotechnology and nanoparticles. So there was a big wow factor, meaning that nanotechnology was going to be the answer to all of our problems. It was going to give us limitless energy. It was going to help us clean up the environment. It was going to cure cancer. It was going to take us to space with an elevator to space. And it was being touted as the next big thing that in material science that was going to transform society and solve a lot of problems. Well, as our researchers who were involved in the creation of this center started thinking about it, I think it was the bioengineer who said, if we're going to use this in the body, we need to think about toxicity. So what do we know about the toxicity of these materials? Well, it turns out we didn't know very much. And then an environmental engineer who was on the team said, and what happens when these things get out into the environment? What do we know about that? And so there was this conversation coalesced where if we're going to start mass commercializing and producing these materials and getting them out into products or into the body or into the environment, what's going to happen? Are there any potential downsides? And so the center was created to look at both the wow and the yuck. And for us, the yuck was very prosaic sort of environmental contamination and toxicity to living things. Whereas in the early part of the 2000s when our center was created, the yuck was something very different. It was these science fiction scenarios of nanorobots self-replicating, consuming us, taking our atoms apart and putting them back together to create, replications of themselves. So the yuck became something, it started off as something different, and we tried to turn the conversation to something more measurable in the lab, more realistic in terms of what the science said, and more relevant to people and the environment.
All right, so before we go too far down that route, I do have to ask, how many times did you read Michael Crichton's Prey, and did it keep you up at night?
Michael Crichton's novel Prey infuriated me. He was a very entertaining writer. So I had read many of his other books, which had been made into films. I was really excited about this one. And then I read it, and I'm like, this isn't nanotech at all. This is microtech. And there's no way these things could do what they do, which is farm and collect among themselves and then go eat the bunny and then eventually, threaten the humans, because they would be blown away by the wind. So I had some technical, I had a hard time turning off the technical skepticism in my brain, especially given how much of an impact that book had on the popular imagination of nanotechnology. And so it really was these engines of creation, as Eric Drexler called them, these fictitious things that both could potentially transform how we make things that we use, but also potentially turn against us. And we're like, wait, I shouldn't have a congressperson asking my center director about nanobots. I should have the congressperson asking her about, what do we need to do to keep people in the environment safe from just toxicity, from environmental and human toxins. So it was a good read, but it was not technically sound, and I'm really glad they didn't make it into a movie.
So it was a roadblock. I mean, it's actually something you had to overcome, not just in the popular opinion, but actually in the opinion of policymakers as well.
I am not kidding you when I say that it did. People in Congress were reading the book, or their staff was telling them the plot, and they were like, is this a thing? Do we need to worry about this? And we were, at the time, really the only center in the world, I would say, that was focusing on the downsides, potential downsides, and was therefore positioned to be able to rebut those arguments and also talk about the real concerns that we should be thinking about. And so it was my policy experience in DC that actually helped me become comfortable having those conversations with policymakers and trying to help steer the conversation to a more, what we thought was a more relevant and productive conversation about risk.
So in many ways, here's an NSEC whose partial job is to do fundamental research to help us understand the world, but you're having to mount an important public relations campaign to make people aware of what actually might be possible.
Yeah, and remember, our center was focused on the sunny side. We used to call it the sunny side of the street as well. We were trying to make cancer therapies. We were trying to use nanoparticles to remove persistent pollutants from water. You know, there was a lot of applications-oriented research that our center was doing. The implication side, the risk side, was at the start a very small part of our portfolio. It was initially the most controversial because many people in the nanotechnology community didn't want any conversation about risk because they were concerned that it would derail the gravy train that was nano at the time. And so we were fighting a little bit of an uphill battle, and science fiction perceptions about what nano might do were not helpful.
All right, so we've talked a little bit about popular understanding of nano, talking about the work that you're all doing is somewhat in its infancy, right? We are beginning to sort of ask the basic questions about what happens to nanoparticles after we're done with them. What are corporations doing at this time? And is your center interacting with corporations that are interested in learning more about what you're doing, or are they sort of looking for the happy side and hoping to ignore the possible downsides?
Well, it's interesting that you phrase it that way because it was like the companies that we were working with that actually encouraged us to explore this. So in the early 2000s, again, still in the wow phase, a lot of really exciting potential opportunities. Many companies that use materials were thinking, how can we use nano? What's in it for us, and how much of our research budget do we want to allot to developing a new class of materials to put in our products, and what kind of benefits are we going to get, and what are the downsides? So every research center that the National Science Foundation funds, these NSECs, were supposed to have an industrial liaison and work with companies and try to the extent possible, commercialize the discoveries that were being made with NSF funding, right? That's a return on the investment for the taxpayer to fund that research and then have it, be commercialized. So whether you do that by creating small companies or whether you partner with bigger companies, there's that component. And I eventually became very much involved with that for our center. And so when the companies were coming to us, they were definitely interested in the materials that we were developing and interested in how we might do research together to create the next thing that they might be able to use. But as conversations around risk started to arise, they were starting to come to us because we were talking about it. And not only were we talking about it, we were talking about it in a scientific and a balanced way, not in a fear-mongering or hypeful way. And we were also having conversations with government agencies, particularly regulatory agencies. We were involved in roundtables where we had non-governmental organizations, public citizen groups, government groups, and really nobody else was doing that at the time. So the companies were very interested in being involved in those conversations so that they could understand what the concerns were from the public side. They would say manage those concerns, but I would say understand them, and then understand the mind of the regulator and what regulatory barriers might be on the horizon if they try to develop this class of materials. In other words, is all of this research R&D funding that they're putting into this class of materials going to pay out, or is it going to end up going awry because of regulatory barriers? And so understanding what they were thinking what the regulators were thinking was an important part of why companies were coming to us in the early days.
All right, so you gave us a little hint there that there weren't just government actors and corporate actors and academic actors, but some NGOs out there, some public citizen groups that probably a lot of the people involved in nano today don't even know of or remember. So can you give us some insights into some of those groups and the impacts that they had and the way they were able to mobilize maybe policymakers and the general public?
Yeah, and a lot of this was us trying to get their attention because nanotechnology was not on their radar screen. And they've got like climate change to worry about. Even 20 years ago, right? There were a lot bigger concerns that particularly environmental NGOs were thinking about. But your listeners will be familiar with the Environmental Defense Fund, National Resources Council, and other big names, Consumers Union, not on the environmental side, but on the consumer side. So these were groups that we were all talking with and engaging with, some concretely, some more casually. But it really goes back to this tiny little group called the ETC group. I'm really going back in the history here, which was this group that was really founded to help farmers and to protect farmers against technologies that might disenfranchise them, particularly genetically modified organisms. Well, they turned their attention in the late 90s to nanotech and said, this is the next thing we need to keep our eye on. And the way that the ETC group changed the conversation was to really focus on the equity issues and who's benefiting and who's paying the cost. And the difference between the developed nations bringing these technologies to the marketplace, but perhaps developing nations bearing the environmental or other costs, or labor markets being disrupted because nanomaterials were going to be replacing materials that are mined in South America, for example. These were conversations that I, as a chemist, was really new to. These thinking about risk in this way. The risk to me was, does it kill the cell? Does it kill the mouse? Does it cause a tumor? But really, risk, as they helped me to see, is a much broader concept. And those early conversations were very influential in our thinking, and really influential, I think, in spawning the ethical, legal, and social implications conversations around nanotech.
I love that you just brought GMOs into the conversation, because one of my memories from the early days was the constant refrain, nano cannot be the next GMO. And it wasn't so much, GMOs have been incredibly wildly successful, but fear of public backlash against nano in a similar way in some areas of the world that happened to GMOs. So I'm curious how you got involved in that conversation, and were you able to help sort of, as you just say, talk about the equity issues in a way that helps people not fear having those conversations?
Yeah, so with nano, we were really looking at, again, we were new to this type of conversation. So as scholars do, we're saying, well, what can we learn from what other people have done before us? And of course, the obvious parallel was to genetically modified organisms, where we learned that there was, huge debate over them in Europe, particularly, not so much as much in the United States, but, the potential for a public backlash to derail the development and commercialization of technology was very real and potentially very economically impactful. So we had to look at the GMO example and say, what happened there? What was the nature of the concern about this technology, and would some of that port over to nanotech? In other words, is it just emerging technology, newness, novelty that people are afraid of? Or is there something about these technologies that they share in common that we need to consider? Or are they different? Maybe people won't feel the same way about things they're not eating, right? The genetically modified organisms are plant foods. They're supposed to be providing nutrition, and yet they have these weird genes in them. And what is that doing to us? So it was very interesting for us to get social scientists to do research on public perception to understand what the nature of the concern was. And it turns out, a fairly basic level conclusion is people are afraid of what they can't see. And nanoparticles are small, and they're afraid of things that are new that they don't understand. And their level of comfort with it is going to track with their level of trust in the people telling them whether to be worried or not. So if they don't trust the government and the government's saying it's okay, then that's not helpful, as we found with vaccines, for example. And so, but if there was some really interesting social science work that went on in the early days to help understand what the issues were, and that was a very high interest to both us, to our industrial partners, and to people in the government, federal agencies as well.
So I'm working with a lot of academics, especially graduate students now, that are increasingly concerned about their work having an impact. They actually want to make a difference in the world. I'm wondering if you have a short story or an instance where you can say that CBEN or some of the activities you're involved with, ICON or similar areas, you move the needle. You're like, after a bit of work, you're like, yes, we used to be here and now we're here. And it was sort of an exciting, fulfilling experience.
Well, I do think that our very existence and our emphasis on the potential negative impacts of engineered nanomaterials and our dedicated and persistent years-long effort to bring this issue to the audiences that needed it did move the needle. And I say that we held some workshops in the mid-2000s where we brought together people from around the world to talk about what do we know, what do we not know, what do we need to know to really be able to use these materials safely. And the conclusions of those workshops ended up influencing government funding decisions. So we started to see the National Nanotechnology Initiative, this federation of agencies that fund nanotechnology research, begin to focus not only on environmental and health risk-related research, specifically carving that out as a component area for focus, rather than just giving some to CBEN and counting it all under product development, but also to focus on the ethical, legal, and social implications, and to fund 2 centers that were looking at nanotechnology in society. So I don't claim credit for the nanotechnology in society centers, but I do think that us raising these issues and talking about them and creating a big tent for the conversations, not just among the academics, but bringing together the coalition we had in ICON, the International Council on Nanotech, the companies, the government agencies, the NGOs, citizen groups, and academics, was a useful model that we were able to talk about things in a measured way without sort of being super emotional about it, and say, what do we need to do here to work with these materials responsibly?
So being a member of one of the Centers for Nano in Society, I have to say thank you very, very much, because it was nice to, as social scientists, it was nice to say, no, there's scientists that are concerned about ethical issues as well, and there's scientists that actually recognize the equity issues. So thank you for being there and for being part of that. So I want to go back to the title of the talk, which is From Wow to Yuck to Meh. How did we get to meh? Or how do you know that we're at meh?
Okay, so first of all, the wow to yuck, I don't think I hit this explicitly, but it comes from a paper that I wrote in 2004 talking about how society is usually really excited about a new technology, and it focuses on the benefits it might bring, and how that perception can change over time as we understand that there's a risk involved. So, for example, asbestos, right? A miracle fabric, a miracle material for flame retarding and so forth, and then it turns out to have these horrible human consequences. So wow to yuck was a way of saying, let's not just focus on the upside here, let's also be proactive and think before we get too far down the road in commercialization what the potential yucks will be, and focus on the real yucks and not the fictitious yucks. And the meh comes in, nearly 15 years after that paper was written, more than 15 years after that paper was written, to where we're at a point now where we're not having big conversations about nano risk. We've funded a lot of risk-relevant research. We've had the dialogues. We've had the legislation. We've had some regulation promulgated, and now nano is just part of the fabric of materials. So it's not something that we're focusing on as a specific emerging technology anymore. It's gotten to that more mature middle age where it's just in stuff, and we don't talk about it, and we don't focus on it. Nobody's saying nano inside like Intel used to do, but nobody's trying to hide the fact that there's nano inside. It's just a thing now. It's become normalized, and the risk-relevant research still continues, but it doesn't have quite the same salience and an impact as I think it had in the early days.
So, of course, all throughout this early days, there's the constant refrain is that we're not governing fast enough. Government is being left behind, and the science is running away. And partially, creation of your center was to gather the data necessary so that governance could actually be more successful. But I'm curious how you see it now, looking back. Did we do it right? I mean, is making nano meh, is that a huge success, and does that mean that we actually balance the science and the public discussions and the governance all along the way? Or did we just get lucky because nano turns out, at least the applications we've largely developed so far, don't have that game-changing major seismic shift and negative possibilities?
So I think that the the work that we did, particularly the work to understand what was it about a nanoparticle that made it toxic, was important to this conversation. Because not all nanomaterials showed toxic effects in the laboratory, right? And so part of what we were doing, and a lot of other people at this point were doing, was saying, what is it about the nanoparticle that makes it? Is it something on the surface of the particle? Is it the way that it's shaped? Because there's this huge variability in nanomaterials. That's what makes them a useful class of products. You can tune them just about any way. So I think having the conversation and really thinking technically about what is it that's going to make a nanoparticle slip over from benign, not recognized by the body or just pass through by the body, to something that's going to stick and maybe have a negative impact. It could be surface charge, for example, if something's charged on its surface. This is the chemist in me talking. And so I think, being able to focus attention on the important questions about what is it that makes a particular nanomaterial particularly toxic to a cell or an animal in the lab helped people think about, well, what can we do to get the benefits without getting the risk? So, for example, a very concrete example is with carbon nanotubes, which are small cylindrical hollow tubes of carbon based on the buckyball that was discovered at Rice University. And nanotubes were found to have a toxic effect in the lungs akin to asbestos. So creating that long-term inflammatory response in the lung that could lead to disease over the course of decades. Very bad, right? You'd never want your brand new, shiny wonder material to be compared to asbestos. Worse than GMOs. And so what we found was that it was really about the exposure pathway. So instead of shipping a bunch of carbon nanotubes, which are these kind of light, dusty materials, you bind them up in a matrix, like a soft plastic, for example, ship them to your customer that way, so they're not breathing them in. So we found ways to either change the material or change the way we handle it to reduce those effects. And that research was done, there are thousands of papers now that talk about measuring these effects, and fewer in the occupational space, but a lot of really good work done by NIOSH, for example. And so I think that helped steer the conversation, and I would like to think that may have headed off some bad stories about nano, but really it came to focus less on what it does if you come into contact with it, to how do you avoid coming into contact with it. So some practical solutions were able to be implemented to help us avoid those negative scenarios.
And did that happen largely because government organizations like the NSF and NIOSH invested in the right research at the right time, or is that corporations stepping up to be involved in it?
Well, I think once the regulators got involved and once the risk research started to be published and you started to get stories, you started to get research like the stuff coming out of NIOSH on carbon nanotubes, that companies were like, okay, we better take this seriously, because none of them wanted to be on the hook, to be the ones that had poisoned their customers, or 30 years from now be dealing with some lawsuit from somebody who was exposed in the 2000s, right? That's what everyone was trying to avoid. And so I think it was the research, and it was the attention paid by government agencies, and the responsibility of the companies together that helped shape that conversation.
All right, so for many of the people that are attending right now, and we'll watch this later, they're assuming, since we're talking about nanotechnology the whole time, that this is obviously your life and the only thing you've ever done. But actually, that's not true. That we are actually taking you back in time right now to revisit maybe not a previous Kristen Kulinowski, but at least an earlier version. So I'm curious now, how are we doing now? How are we handling emerging technologies today? What did we learn from, or did we learn from, the experience of nano in sort of the first decade of the 2000s that we might be using as we think about moving forward now with nano and other technologies?
Right, so nano is just the emerging technology of the 2000s. And of course, emerging technologies are always emerging, so there's always going to be another one. And they're not all materials-based, or they don't all present the same set of issues and challenges that nanotechnology does or did. But definitely the issues of how do you handle an emerging technology where, as you said before, the research and technology development is getting out ahead of the government regulators' understanding of it, is still a very salient question to ask. So what I would like to think is that the way that we handle nano has informed future emerging technologies. But I will also say I don't particularly have any evidence for that assertion. It's kind of like a, hey, we did it and people talk about it, so maybe it helped. But I will also point out that the world is a very different place than it was 20 years ago. And so there are, different conversations happening that it would be hard pressed for any but a few very niche actors to have been having 20 years ago that are happening today around the environment, around environmental justice. We talked, you mentioned equity before, but we haven't really hit on that other than obliquely. And those conversations are very different today. So I think when we talk about emerging technologies today, we need to do it in the present context of many more, ground-up efforts, bottom-up efforts to, and citizen-oriented and advocate-oriented efforts to address the problems of the climate and the problems of equity and justice that can be intertwined in the area of emerging technologies.
All right, it looks like we're beginning to get some questions directly from the audience. So maybe I'll sneak in one of these now since I think it's relevant. So Kristen Kulinowski asked, could it be that the early concerns were just ahead of time? Nano today is more than just nanoparticles or materials. For example, former microelectronics becomes nanoelectronics. The implications of advances in IT enabled by nanotechnology are truly changing society, AI being one example.
Yeah, I do think we were ahead of our time. We certainly felt that way in the early days when people just said we shouldn't even be talking about this stuff because there's no industry there yet. There's no big product base. It's like you address the problems after they emerge. And we were like, no, you address them before they emerge. Nano today is more than nanoparticles and materials. It's part of the next generation of emerging technologies, and AI is a great example. But the problems and the issues around artificial intelligence are not to do with whether or not you're breathing something in your lungs that might hurt you. They're around privacy. They're around racial profiling and the misuse of data that's going to exacerbate existing inequities. And so I think the anticipatory nature of what we were trying to do is still relevant for emerging technologies, but you have to look at the specific technology that you're thinking of and then say, what are its specific issues, maybe completely different from nano.
And it looks like this Blue Jeans has multiple ways to ask questions, and I missed one 10 minutes ago, so I apologize to Kara Greiger. But actually, she's asking more specifically about factors influencing perceptions, like nano in food being a particularly hot flashpoint for conversations about the appropriateness of using nano or not. So, do you have any insights or any memories of nano in food from back in the day, or how those discussions have continued?
Yeah, absolutely. In fact, I attended a conference in Germany on nano and food, and the nano in food is multi-dimensional. So there was a lot of nanotechnology in food packaging, and that's just whatever you're wrapping your stuff in. Well, the questions are, does the nanoparticle get into the food, and what are the consequences of ingesting it? Most of the research on ingestion did not show that it was particularly problematic as an exposure pathway. A lot of the exposure pathway of concern was inhalation of these particles into the lung. But nonetheless, people unintentionally ingesting nano food packaging materials. Then there were nanosensors on food, right? So could you put a sensor on a package of meat that would turn a color when the meat was spoiled so that you knew not to buy it or to throw it away if it was in your house? So that was, a new frontier that was talked about. Nanotechnology in agriculture for being able to sense local conditions in the field and know exactly where to deliver nutrients or water, and then potentially even having nano encapsulated fertilizers. So many applications of nano in food. Didn't see so much of the concern about it. I think one of the big concerns in the early days was around unintentional ingestion of things like sunscreens, right? So if sunscreens have nanoparticles in them and a child is spraying the sunscreen on them and then, children put their fingers in their mouths, is that going to be a problem? And likewise, if we're I remember the teddy bear, the nano silver teddy bear which was, nanosilver is a potent there it is, a potent antimicrobial. I swear I didn't even make the connection.
Yeah, you're sitting right behind me, right here.
Yeah, right. So for those of you who aren't familiar, nanosilver is a potent antimicrobial agent, and so it kills pretty much every bacterium, virus, algae, and so forth. And so the thinking was, well, kids put stuff in their mouths and then it gets on the floor. That's gross. Let's put something to reduce the microbial content of that. But then you're just giving your child something that potentially has nanosilver in it. And what happens when you ingest nanosilver? Well, you have to ingest a lot of nanosilver for it to have an impact. It's one of the lesser toxic nanomaterials in major commercial production. But these were the kinds of conversations. Either it wasn't so much about intentional ingestion of nanoparticles as much as incidental based on the food packaging or the nano being in these products that could incidentally make it into your digestive system.
So one quick follow-up on that. You mentioned earlier the studies that showed the potential toxicity of carbon nanotubes. And I know that, science doesn't work such that you run one experiment and then show, hey, something is totally safe. But as some of these studies came in, they began to show you that, oh, actually the human body's pretty good at processing nanoparticles and flushing them out. Were there senses of relief? Were there moments where you said, oh, thank goodness this is not toxic in the way we were fearful it might be?
Well, that's a very good point, and it's something we always tried to bring into our conversations about nanoparticle toxicity. So very, very persistently trying to get the message across. First of all, not all nanoparticles are the same. So just because it's nano doesn't mean it's going to, have the same effect as another nanoparticle. Second, what it's made of and what its form is and all of this stuff, all of that, physical and chemical characteristics, they all matter. And then we're talking about experiments in cell culture. So we have a petri dish, we dose it with a bunch of cells, half the cells die. What does that mean for the human body? Very little. So let's not overinterpret the early studies about risk. They provided us more with a pointer to where more research was needed on more complex biological systems than it did tell us, oh, you shouldn't ever touch a nanosecond. People have been drinking colloidal silver for a long time, since the early Roman Empire days, I think. So being able to provide that context for what the research actually means and not over-interpreting or getting too spun up about it was an important part of the public communication piece of what we were trying to do. But always encouraging that next level of research happen, right? So that we don't just satisfy ourselves, oh, it's just cells and culture. We say, okay, maybe that's a screen for what a particle that we need to do more research on before we do expose people. So we always cautioned to be careful if you don't have really good exposure or hazard data coming out of the lab. And that was the case for a very, very long time.
Yeah. All right, so David Gottfried had to get into the conversation and is curious about the vast majority of us have welcomed lipid nanoparticles in the form of COVID vaccines without much bother. Is this meh, or are we just focusing on other aspects to yell about, not worried about the nano part?
Well, that is a toxic minefield to wade into. So first of all, there's these rumors that there's nano chips in the vaccines, which is ridiculous. Nano, like I said, nanoparticles have become just part of what's in stuff, and they give that stuff, that technology, some advantage, characteristic that's beneficial, and we don't think too much about it. Now, I will tell you that back in the day when I was, participating in a citizen jury, which is a kind of, it was over in the UK by the Demos group. It brought a bunch of citizens together and started to have a conversation about nano, and they were talking about, well, I don't want nano in my face cream. And so I held up the bottle of face cream and I said, do you know what blah, 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 methoxy, blah, blah, blah is? And they were like, no. And I'm like, so if you're not asking questions about that thing, why are you asking questions about the nano-ness? So it was revealing to me that people can be very selective about what they choose to get worried about, or they can be influenced to be worried about something that's potentially not all that worrisome. So I do think we're a bit at meh for that aspect of the COVID vaccine.
The government trust you mentioned earlier might be somehow involved in the current discussion as well. All right, so Kara Greiger has added another question where she's going pretty detailed, but she would like your take on EFSA's recent decision to consider titanium dioxide no longer safe as a food additive based on genotoxicity studies of nanoparticles. Kristen, I don't know if Kristen has been up to date on all the details of the latest nanoparticle research, but I'll throw that out there to see if you have a response.
So not familiar with this most recent decision, but of course we were tracking titanium dioxide toxicity all throughout the 2000s because that was one of the materials that was in highest commercial production. And, you know, it was the material that's also in some of the mineral-based sunscreens, that or zinc oxide. So there were lots of questions about what happens when titanium dioxide gets in your body or on your skin, right? So you're rubbing this on the skin directly. Is it phototoxic? And the studies that were coming out at the time showed titanium dioxide to be fairly benign in the whole body system, right? It could kill cells in culture, yeah, it could induce inflammatory responses, but again, the body has ways of accommodating and coming up with lots of defenses against things that are foreign. So I would be very interested to look at that research to see what new. There were some glimmers of genotoxicity with titanium dioxide, but I think it was still a little bit early for anybody to have been, like you said, one study doesn't determine what a regulator is going to do. There needs to be a body of evidence. It needs to be pretty compelling. It needs to pass through a lot of scrutiny because regulators can't, in the U.S. anyway, can't move super quickly, and nor should they. So it would be interesting to go back and look at the body of evidence on titanium dioxide that's come out in the last 5 years to understand what motivated that decision.
So we've been talking a little bit about public perception of technologies and whether we're at yay, yuck, or meh. I'm curious, I mean, is that just in your idea and looking back at all the things you've done, is that simply the progression that we just go through? We go from wow to yuck to meh? Or is the general public interacting with technologies or considering technologies in a new, more complicated way today than maybe we did 20 years ago?
Well, I think if you look at things like AI, do people even know where it is affecting their lives today? So if you are someone who is, for example, particularly concerned about privacy, then you may not want your image to be captured by some camera on the street. You may be a little skeeved out by what you might perceive to be the surveillance state and the ability of some computer to categorize you or conclude something about you based on, data about you, like your image. There's science fiction movies that, use this to great effect. On the other hand, we all accept a lot of invasions into our privacy to get the benefits of the technology. So I still think at the end of the day, this is a rather personal decision about what the threshold is, what personally bothers you versus what you're okay with, and what you're willing to put up with to get the benefits that you seek. Who would have thought that we would have such powerful little computers in our pockets? And who would have thought that we could opt into a system that tracks our movements so that we could get notifications if we came into contact with anybody who reported a positive COVID test? Well, I know lots of people have not opted into that system, but plenty others have for the potential benefit that it brings. So I don't think Nano is any different. It's just, what is the benefit versus the risk? That, in the end of the day, is conversation, and it's often a very personal decision.
So we just talked about changes in the public. What about corporations? You sort of described them in the early 2000s as trying to downplay any negatives while simultaneously preparing for possible toxic issues. Are we similar place today, or are more and more companies, for instance, talking about equity issues, which may not have been at the forefront of those discussions early on in Nano world?
Well, I do see, corporate social responsibility was certainly a thing 20 years ago. That's not new, but it seems to have gotten much more vocal and much more prominent. And I don't know if that's just a branding thing or if there's real concern around public backlash to not only just emerging technologies, but policies and commercials and things, right? I mean, if you say the wrong thing as a corporation, you might not be able to have the Super Bowl in your state or something. There are serious consequences that can redound to these companies if they make missteps in the public's mind. And so I think around the issues of equity, around diversity, equity, inclusion, around the appropriate use of technologies, I would think corporations are paying a lot of attention to that. There's also just a lot more media and social media engagement between companies and their customers and the public than I think there was even 20 years ago. Those are all factors.
All right, Chuck Garassi has, I think, a statement which I'm going to turn into a question. So he's looking at quickly moving into advanced materials and advanced manufacturing. He's suggesting that the audience and conversation should be broader. Are we, if nano is meh, are we losing out on really important opportunities right now to engage in and facilitate a public discussion about nano, or are there new technologies that we should be focusing those efforts on instead?
I definitely think nano should not be no longer part of the conversation. But I'm not sure that nano as nano is really where the conversation should be. So I take Chuck's point that, advanced manufacturing, for example, 3D printing, which produces nanoparticles, incidentally, by the way, AI, biotechnology, DIY biotechnology, geotechnology, geoengineering, all of these things are potential game changers, and some of them bear very close connection to nano and some don't. What we tried to do was create a model and a recognition that one needs to think about these things early, one needs to have broad conversations around how to handle the risk. And now recently, who gets to decide what the risks are, right? Who's in the room, who's at the table, who's speaking for whom, and who's left out. And that's something that's very new.
Yeah, it's interesting. So when I think back to the early days of nano and trying to figure out, you and I had this conversation the other day, exactly how many people were at ETC. Well, I think we came up with maybe 3 or 4, and yet they were, sparking news coverage around the world. Today we have, Greta Thunberg, who, not only one person, but pretty young person, again, facilitating conversations that wouldn't otherwise happen. So any comments on sort of the more recent social movements, the more recent non-government organizations that are trying to facilitate conversations about our future that we might not otherwise have?
Absolutely. I think the younger generation is much more fluid and fluent in social media and in novel ways of engaging public. They're also very concerned about their future and what the olds like us are leaving them with. And they're not being silent about it. We also have, connected to that, the White House making very public statements about equity and environmental justice and incorporating statements and policies around that into all of their scientific policy making. So the president has issued several executive orders, which is like the pinnacle of a presidential statement, directing agencies to incorporate issues of equity and environmental justice and racial equality. And there's a phrase to ensure that all Americans enjoy the fruits of the scientific and technology that the government is funding and that companies are funding. And this is really new language, and it's persistent, and it's across the entire science technology policy agenda of this White House. And that, coupled with, and maybe that's a mirror for what they're seeing happening in society, but it's a very different landscape from a few people crying out into the wilderness that this is a problem to where we're now constantly being asked to look at the implications of what we're doing and look at who it's affecting and look at, are we putting the plants in the poor neighborhoods to pollute those people and not, but we're enjoying our iPhones and our watches and so forth. And so I think those conversations are productive and useful, and I'm excited about what that might mean for a whole next generation of technologies and what it might mean for climate mitigation.
All right, so you might have just answered this question, but I'll see if you have any other answers. You're now in 2002, and you're being told what the world is like in 2022. What are the biggest surprises? What are the things you would not have expected, or happy to see have happened?
Well, I am happy to see all of this public engagement, and I'm happy to see politicians picking up some of these big important issues. And it's no longer, just a few environmental NGOs that are talking about the climate. It's really become it's become such an issue that young people are, concerned about their future because they are hearing so much about it. I don't like the concern part, but I like the fact that it's a big part of the conversation. So that and having companies really being called to account and being held accountable through personal action, through social action, through social media. There's very little wiggle room now to make big mistakes, it seems like, because it's going to be found out and you're going to get canceled. Not you.
So Kristen, I spent a lot of time working with graduate students, and some of them are beginning to think, I want to make sure my work makes a difference. I want to make sure that, that the work that I do 20 hours a day in this lab isn't simply read by a handful of people. You've certainly taken that to the extreme by moving from the lab to being director of one of the most important science policy organizations in the US. Do you have any advice for those graduate students? How they can make sure that their work is actually having an impact and trying to create the better world, which many of them were drawn to science or engineering to create?
Well, that's a big question. I can only tell you what I did, which was to, care about the issues, patiently work to bring other people into the conversation, stick to what I knew about, right, which is why we sort of brought in social scientists to help us with that piece, build credibility rather than trying to go for shock value. These were all elements of our success, because when we spoke, and we spoke particularly as ICON, which meant everybody, all the different coalitions had to agree with what we said, it was a powerful thing because it was very hard to achieve. It was very hard to get, the big company, chemical company, to agree with a statement that, that the environmental NGO would also agree with. So we were cautious. I mean, we were bold in the sense of what we were trying to do, but we were doing it very deliberatively and very carefully to maintain our credibility. And I think for scientists and engineers, people who are, or social scientists who are training in a scholarly way, to maintain that credibility is important. And that means being true to what your data are telling you and speaking to that. And the challenge then is finding a way to communicate that to the public or whatever audience, that you are interested in, that's not your peer audience, in a way that's both accurate, relatable and understandable, but also providing a solution or another question that is important to answer. So I think that's what I'm proud of that we did with CBEN and ICON.
All right, we have 5 minutes left, and I want to make sure if there's something I didn't get to that you wanted to make sure we got to, Kristen. Is there anything on the list that we should make sure we include?
I think this has been a lot of fun for me to go back and think about where we were. And I'm going to be thinking about your question now about what would my 2002 self say to my 20-year-old self, other than maybe exercise more and stretch more. That's a personal thing. But, I think that we just have to remain aware of the context we're operating in now. Look to the future, and I love the anticipatory governance model. I think it is important to say, what if, what are the things that could go wrong? What could we do to prevent that, instead of waiting for it to happen and then trying to clean it up afterwards? That was our main message, and we were doing that in the lab, we were doing that in the public arena, we were doing that in the regulatory space, and I still think it's a useful model. And I would encourage those people who are working in these areas to consider the implications of what they're doing and stay on the sunny side of the street.
All right, so I'm going to sneak in my own personal question then. You sort of hinted earlier at something which I vaguely remember, which was the DuPont collaboration with the Environmental Defense Fund. This is a major scientific corporation partnering with a pretty large NGO that don't always necessarily see things the same way. And I know at the time we were all very excited that this partnership was happening, simply because it was getting conversations going that wouldn't otherwise happen, and it seemed to be productive rather than antagonistic. Are there any partnerships today that you really see sort of bridging some divides that are giving you hope for creating the conversations and perhaps promoting the policies or the engagement necessary to move us forward?
So I can't speak to the nano space because I've been out of that for a while. I'd have to think about that. You do sometimes see some strange bedfellows, people organizing particularly on the area of privacy. You can see people on really different sides of the political spectrum coming together around issues of privacy related to emerging technologies like AI, for example. Those partnerships and alliances are always intriguing because you don't expect those people to well, they're strange bedfellows, right? So that's exciting. But other than, corporations, I'd have to give that a little bit more thought. Nothing's coming to mind right now. Do you have something that you see that you'd like me to respond?
Well, I mean, the only thing that I was going to give you a chance to talk about is the current Office of Science and Technology policy and how there is some expertise and partnerships in there right now that we didn't have 20 years ago.
Yeah, so that's true. So President Biden created a new position. The Office of Science and Technology Policy are the president's science advisors, basically. It's an office that's in the White House that advises the president. And my organization outside of the government supports that office with Analyses. The president announced, created a position, Science and Society. So instead of having a science division, it's now a Science and Society division, and brought in a card-carrying social scientist, Dr. Alondra Nelson, to lead that office. And she's an African-American woman, and she knows very well and has spoken about how she knows the people who have been left out of conversations around the risks and benefits of science, and has written books on this subject. And he appointed her to this very prestigious position, and now she's actually acting OSTP director until a permanent nomination can be confirmed. So that's new. The issues around climate and environment, now there's a division of climate and environment within OSTP. There was always climate and environment work going on in the White House, but now it's its own office. So the messaging around what this White House is doing is different. And instead of having like science, technology, national security, they have these interesting intersections, which really, I think, recognize and acknowledge the fact that it's not just science, it's not just technology, there's a lot of intersecting circles, and we want to make sure that we are in the right sweet space.
So the joke of historians of science policy for a very long time was anybody in the world could be the president's science advisor as long as you're white, as long as you're male, and as long as you are a Ph.D. physicist. And so the fact that the current acting assistant to the science advisor, the president, doesn't have any of those is kind of exciting. So.
Well, it was quite something for the president to have nominated a biologist for the first time. So, yeah.
Indeed. Well, thank you very much, Kristen. I'm afraid our hour is at an end, but I've had a great time, and so great to catch up. And so I appreciate that you continue to smile about the future, and that we have made some serious headway, and it makes me very pleased.
Well, thanks so much for having me, Jamie. It was so much fun to talk to you, and thanks for everybody who tuned in to listen, and those of you on YouTube who will see this.
And thank you. I want to give my thanks also to Kristen and to Jamie and to all of you who are attending. And we'll see you at the next NNCI webinar. Stay tuned for details. Thanks very much.